Alright, let's look at the homework 3.1, problem number 7. Alright, so we have this rational function, and first we have to find critical numbers. Alright, so let's do that. Alright, so first we need to take the derivative. So f prime of x is equal to, alright, so we're going to square the denominator. So we have x squared plus 4 squared. Alright, derivative of the top is 2x times the bottom, x squared plus 4 minus top is x squared, and derivative of the bottom is 2x. Alright, so I'm going to pull out the 2x here. 2x is in common. So here, I'm going to have a 2x here and 2x there. So those are pulled out here and divided only once. Alright, then we have what's left is x squared plus 4. And so that will take care of those guys. And then we have minus x squared. Alright, so we have a minus x squared. Alright, so we can cancel x squared here and a minus x squared there. And the denominator is looking good, so I'm going to just keep it as it is. So x squared plus 4 squared. Alright, so if you multiply here 2x and 4, so we will get 8x on top over, then you have x squared plus 4 squared. Alright, if you set that equal to 0, we can see that we set 8x equal to 0. And divide through by 8, we know that x equals 0. Alright, so critical number is 0. And this derivative is always defined because the denominator is never 0. Alright, so let's type it in. So there's only one critical number, 0. Alright, so submit for testing. Alright, I came back and looks like we got this one correctly. Alright, then we want to find the open intervals on which the function is increasing and decreasing. Alright, so let's do that. Alright, so I'm going to do a number line. So here's the number line there. Alright, so there's only one critical number, so it's 0. Alright, so if you look at the derivative, so I'm going to look at the, say, f prime of, say, -1 or something like that. Alright, if you plug in -1 here, derivative is definitely negative. Right? And if you look at the, let's see, anything bigger than 0, so I'll try 1, f prime of 1, so the derivative is positive, right? So if you look at the original function f, you can see that this is going to be, so derivative is negative, so it's a decreasing on this interval. And after 0, it's going to be increasing because the derivative is positive. Right? So it looks like it's increasing on the interval from 0 to positive infinity. Right? We could have included the 0 there, but since they're looking for open interval, so it's from 0 to infinity. And here, decreasing from negative infinity to 0. Right? So let's type it in. Alright, so we have, let's see, from 0 to infinity. Alright, infinity, let's see if I can find a symbol here. Alright, and here, decreasing on negative infinity to 0. Alright, so let's check the answer. Alright, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, so if you want to sketch this graph, so let's bring out the calculator. Alright, so I'm going to just erase this. Alright, so we have x squared, so we have x squared and divided by, alright, parenthesis, x squared plus 4. Alright, and hit enter. right? And then maybe hit graph there. Then we might be able to see the picture, right? So it looks like that. And if you zoom it a little bit, that you can see it a little bit better. But let's see, I'm going to just change the window size. So I'm going to, let's see, go down. And I'm going to put the Y mean to be a negative maybe 3 or something like that. And Y max 3. Then hit graph. So you can see a little bit better, right? So you can see that the before 0 and before 0, right, graph is decreasing. After 0, graph is increasing. So it agrees with what we found. All right, that's it. I hope that this was clear.